If you're watching the notes right now, then you're going to want to have a calculator out and also your notes handout so that you can follow along. Throughout the video, feel free to pause if you need more time, especially when we get into the practice problems. I want to make sure that you get a chance to try them yourself before you hear me go over the answers. So we're going to start off talking about the metric conversion chart and the metric conversion system, which is a lot easier to use than the empirical or English system of measurement. And it makes a lot more sense because the metric system is based off of powers of 10. Whereas in our English system of measurement, we have to remember all of these different numbers and no one's really sure where they came from. Like, who made 12 inches equal a foot? Who said that 3 feet were going to mean a yard? Who said that there was going to be 8 ounces in a cup? And why are there 5,280 feet in a mile? Those seem like really random numbers. They make it difficult to remember and even more difficult to use in math because a lot of times it forces us to use calculators when in the metric conversion system of measurement we can simply just move the decimal place, and I'll show you how we do that after we talk about the prefixes. So we have a mnemonic to remember the prefixes, and they're not all of them, but they're the ones that we're probably going to see the most often, and that's why we see 7 steps in front of us. So I'll show you the mnemonic, and it goes like this. King Henry died by drinking chocolate milk. And so K stands for kilo, H stands for hecto, D stands for deca, B stands for base unit, which we'll talk about in just a second, D stands for deci, C for centi, and M for milli. So when we say base units, we're talking about grams for mass and liters for volume, and then meters for length, just to give a few. And so those are base units because they don't have any prefixes yet. Whereas if we put a prefix in front of it, it changes the value. So, for instance, we can make all the base units a value of 1. So when we say gram, we mean 1 gram. But when we're talking about deci, so a decigram, we're talking about 0.1 grams. Or in other words, we could think about it as 1 over 10 grams. When we're talking about a centigram, we're talking about 0.01 grams. Or if we want to think about it in fraction form, that would be 1 over 100 grams. And then a milligram is going to be 0.001 grams, or in fraction form, 1 over 1,000th of a gram. On the flip side, a decagram would be 10 grams, and a hectogram would be 100 grams, and a kilogram would be the same thing as 1,000 grams. So this makes our life so much easier when we go to using these units in math, because we can simply move the decimal to make a conversion, and I'll show you what I mean. So let's say I have 1,780 centigrams, and I want to know how many kilograms that is. Well, if I look at my stair step of King Henry died by drinking chocolate milk, then I can count and say that, well, there's 1, 2, 3, 4, 5 different stair steps to get from a centigram to a kilogram. And I had to go up the stairs, so I had to go to the left. Well, we have an unwritten decimal place right here. So now I can just go 5 places to the left. So 1, 2, 3, 4, and 5. So I will have 0.01780 kilograms. And that's just really nice and easy. I didn't even need to use a calculator for that. Okay, well, let's try another one. Get rid of this. Okay, so let's do another one. Let's say I have 2.46 kiloliters, and I want to know how many centiliters that is. Okay, well, centiliters to kiloliters, again, is changing 5 places, but this time, to go from kiloliters to centiliters, I had to move to the right. So then I'm going to want to take this decimal place here, and when I have 2.46, I'll move it 1, 2, 3, 4, 5 places. Fill those places in with zeros. So my final answer will be 246,000 centiliters as my final answer. So it's all about powers of 10 and being able to move that decimal place over however many stair steps you had to go to get to the new prefix. And again, everything is based around the fact that we've got these base units of grams, liters, and meters that just stand for having one of them. Okay. With that being said, let's get into dimensional analysis. We're definitely going to be using a lot of metric units and metric conversions because that's what dimensional analysis is. Notice here it is unit conversions, going from one unit to another unit in the most efficient way possible. So I've got this challenge problem for you. Without knowing anything about dimensional analysis just yet, I want to see if you can solve this problem. It's called the Jabberwocky problem. It says there are 20 tum-tum trees in the Tolgi wood. In each Tolgi wood there is one Frumious Bandersnatch. There are 5 Slithy toves and 2 borogoves. There are 2 momras per Jabberwocky. There are 2 jubjub birds for every 200 tum-tum trees. There are 200 momras in each borogrove. There are 5 jubjub birds per Slithy tove. And I want to know, if there are 5 Frumious Bandersnatches, how many Jabberwocks or Jabberwockies are there? So I want you to take a minute, or a couple, and see if you can figure this out without any prior knowledge. You can go ahead and pause the video and resume once you've given it your best shot. Okay. I'm assuming that you tried it. It should have been pretty difficult, especially if you have no prior knowledge of dimensional analysis, because dimensional analysis is going to make this problem so much simpler because it's a structured way of canceling out one unit and getting to the next unit to find the final answer efficiently. So we'll go ahead and use this to show us how dimensional analysis works. So I'm going to kind of make this smaller, push this up here, but not too small because I need to be able to read that. Okay. So when we're doing dimensional analysis, we always want to think about what we're starting with unit-wise versus what we want to finish with. So in bold there, again, it says if there are 5 Frumious Bandersnatches, how many Jabberwocks or Jabberwockies are there? So my 5 Frumious Bandersnatches is what's called my given. That was provided to me in the problem. So in almost all cases, I will go ahead and I will put that over 1. So I'll write 5 Frumious Bandersnatches. I'm going to try to save some room here. Just write FB. Okay, now I need to get rid of Frumious Bandersnatches as a unit because that's not what I want to end up with. I want to end up with Jabberwocks. So I'm going to try to find where there's Jabberwocks in one of the other statements. And I'm looking and I see that there are... Okay, in the second statement, in each Tolgi wood there is one Frumious Bandersnatch, and I can try to get rid of Frumious Bandersnatch if I set it equal to the Tolgi wood. So I'm going to create an equivalence statement here. Okay, so if I want to try to get rid of the Frumious Bandersnatch, then that means I have to have the Frumious Bandersnatch in the next equivalence statement. in the denominator, since my first Fermi's Bandersnatch right next to the 5 is in the numerator. Anytime you divide something by itself, you cancel it out. You get rid of it. And that's what I'm trying to do, because I don't want to end up with Fermi's Bandersnatches. I want to end up with Jabberwocks. So it said that 1 Fermi's Bandersnatch is equal to 1 Tolgi wood. And this is what I mean by equivalent statement. 1 Tolgi wood is the same or equals 1 Frumius Bandersnatch. Now I can cross off the Frumius Bandersnatches, and I'm at Tolgi wood. That's not what I want to end up with, though, so I need to figure out how am I going to get rid of Tolgi wood. Well, let's look back here and find where Tolgi wood is. Okay, so in the first statement, it says there are 20 tum-tum trees in the Tolgi wood. That's going to be my next equivalent statement. So 1 Tolgi wood and 20 tum-tum trees. Notice how I'm purposely putting my Tolgi wood underneath my tum-tum trees, because in order to cancel out the Tolgi wood that's in the numerator up here, I have to have a Tolgi wood in the denominator over here. Just like I said, if you divide anything by itself, you cancel it out and you get rid of it, which is what we wanted to do. We don't want to end with Tolgi wood. We need to get rid of it. Same thing with our tum-tum trees. I don't want to end it with tum-tum trees. I need to end with Jabberwocks. So let's figure out how we can get rid of tum-tum trees. Well, I know that tum-tum trees is going to have to go down here. Always let the last numerator lead you into the next denominator. You know you need to cancel it out. Alright, so it looks like one of my statements says there are 2 jub-jub birds for every 200 tum-tum trees. So 2 jub-jub birds for every 200 tum-tum trees. Alright, now I can cross off tum-tum trees. Now I'm at jub-jub birds. How can I get rid of jub-jub birds? Well, it says there are 5 jub-jub birds per slithy tove. So 5 jub-jub birds per 1 slithy tove. Okay, now I can cross off my jub-jub birds. Probably going to have to come down here and continue this on the next line. So I'm going to need slithy tove then to be in my denominator so that I can cross it off. So I need to find what is the equivalent of a slithy tove. It looks like 5 slithy toves are the equivalent of 2 borogroves. We'll make that BG. Okay, now I can cross off my slithy tove, cross off my slithy tove. And now I have borogroves. Well, hopefully I'm getting close to Jabberwocks. This is kind of a long time coming. So let's look for where there's a borogrove. Okay, so I see second to last statement, there are 200 momras in each borogrove. So 1 borogrove equals 200 momras. Okay. Now I can cross off my borogroves, cross off my borogroves. Awesome, now I'm with momras. And it looks like I'm nearing the end here. It says there are 2 momras per Jabberwock, so 1 Jabberwocky. Okay, now I can cross off my momrath, cross off my momrath. Now I'm ready for my final answer. So I need to multiply across all of my numerators and then multiply all of my denominators and divide the numerator by the denominator. And what I end up getting for my final answer is 8 Jabberwocks or Jabberwockies. Okay, and I ended with 1 sig fig, notice, and I started with 1 sig fig because when you are looking at your given right here, so if there are 5 Frumius Bandersnatches, how many Jabberwocks are there? That's the question. 5 was what I was given. I need to make sure that my final answer is not more precise than what I started with. So I have 1 sig fig here, 1 sig fig here. I have my units. Notice I showed my units all throughout as well. I'm good to go. Okay, let's try that in less of a weird way and without all the crazy words. So the next one is how many weeks are the equivalent of 520 hours? So in this case, that's my given. Always think to yourself, how many sig figs is that? Hopefully we're saying 2 sig figs, since that 0 is a placeholder. Our 2 significant digits here are 5 and 2, so that means that my final answer will have to be to 2 sig figs as well. That's kind of getting ahead of ourselves. So let's start off with setting our given over 1. So 520 hours, HR for hours, over 1. Now, I'm trying to get from hours to weeks. Again, this is why it's called dimensional analysis, because dimensional analysis is unit conversions, going from one unit and ending with a different one. So I know if I need to get rid of hours here, then I need to have hours as my denominator for the next one. Well, how can I get closer to weeks? Well, let's go through days then. So I know there's 24 hours in one day. And then I can cross off hour, cross off hour. That should look like an X. Okay. Now I'm at days, but I need to end with weeks. So I'm going to go ahead and put days down here so that I'm going to be able to cross those off and cancel out those units. I know that there's 7 days in 1 week. And look, I am ending in the units that I needed to end in because I can cross off the days, and I have just ended with weeks, which is what I wanted. Okay, and then final answer calculator ends up giving you, I want to say 3.0952, something, it might even keep going. But if we have 3.0952 and I needed 2 sig figs, then this is going to become 3.1 weeks as my final answer. Okay, let's do that again. This one says, how many centimeters are in a 100-yard football field? Okay, so this is my given. I'm going to set that over 1. I take note of how many sig figs I have. Hopefully we're thinking that we have 1 sig fig here. These 2 zeros are just placeholders. This one is my significant digit. If I only have 1 significant digit in what was given to me, then I can only have 1 significant digit in my final answer. So I'll go ahead and put 100 yards over 1. I need to try to get to centimeters. Notice at the bottom here, they're trying to help me out. They're saying, here's a conversion that I can use. This is considered an exact number. 2.5 centimeters equals 1 inch, and in fact, we can be a little bit more specific than that because it really should be 2.54 centimeters equals 1 inch. So let's use the 2.54. So at some point, we're going to want to think about using that. Okay, so back to my 100 yards. How am I going to get from yards to centimeters? Well, let's go through feet. I know that in 1 yard, there are 3 feet. That's an English system right there. So we're not even in metric just yet. We're going to have to cross over to metric shortly. But right now I can cancel out my yards, which is good because did not want that. Okay. Well, I know that in 1 foot, I have 12 inches. And now I'm going to be able to use the conversion at the bottom that they gave me, because I can cross off the feet, and now I can set 1 inch equal to 2.54 centimeters, and then get rid of my inches. And notice that I am ending with the units that I needed. I needed how many centimeters there are, so that should always be the only unit that you did not cross off like you crossed off the other ones. Okay? And then final answer for that, if you plug it into the calculator, you should get 9,144 centimeters. However, we said we can only have 1 sig fig for our final answer. That's not 1 sig fig, but this is 9,000 centimeters is our final answer. Okay, this one's a little bit different. This time our given has it's a derived unit. So it's not just 17 centimeters, it's not just 17 seconds, it's 17 centimeters per second. So when we set up our given here, it's not just going to go over 1, it's going to go over 1 second. So we want to be careful of that. So 17 centimeters over 1 second. And then notice I need to end in meters per hour. So I need to go from centimeters per second to meters per hour. And how we're going to do this is we're going to accomplish one at a time. And it doesn't matter what order you go into. Let's just say that we're going to start by converting the time first. So I'm going to tackle seconds to hours first. Okay. So I know I need to get rid of seconds, so I'll make sure that seconds is up here so that when I divide my numerator and my denominator, the seconds will cancel out, since I don't want to end with that. Now, how am I going to get seconds closer to hour? Well, I know that there's 60 seconds in 1 minute, and I can get rid of seconds that way, and I know that there are 60 minutes in 1 hour, and then I can cancel off minutes. Notice how when I want to cancel a unit, I always make sure that it's on the opposite side of the equivalent statement fraction so that when they divide by themselves, they cancel each other out. Now I'm at hours, so that's awesome. But right now I'm at centimeters per hour, and I need to end with meters per hour. So I'm just going to keep this going. I had, if you notice, centimeters as my numerator up here, so if I want to get rid of centimeters, I need to make sure that centimeters is going to be down here for my denominator. So I'm going to put centimeters here. And according to King Henry died by drinking chocolate milk, I know that I have 100 centimeters for every 1 meter, and now I can solve. So I can multiply the numerators with each other, and then I can multiply the denominators, and then divide what I got with the numerators by the denominators. That will spit out for me 612 as my answer in the calculator. But if you notice, I've got 2 sig figs here in my given, so I can only have 2 sig figs here. Right now I have 3, so that's a problem. So I need to turn 612 into 2 sig figs. So this is going to be 610 meters per hour. Also notice that I'm left with meter, that was not crossed off. I'm left with hour, that was not crossed off. I guess I should have remembered to cross off my centimeters. But the point is that you know that you have the right units at the end because they should be the only things that you didn't cross off. Okay, let's try this one. So a hawk can fly at 62 miles per hour. How fast is this in meters per second? Why don't you go ahead and take a minute to try this on your own, so you can pause the video, and then when you're ready to see if you successfully converted it, then turn it back on. Okay, so let's see how we did. So we have a given here that's 62 miles per hour. So I'm going to go ahead and write that. 62 miles over 1 hour. And I need to go from miles per hour to meters per second. So it's kind of similar to the last one, where we have 2 units that we need to convert to 2 different units. And it doesn't matter which ones I do first. Look at the bottom, it says the conversion to use. It gives us a hint that 1 mile equals 1.60 kilometers. So I definitely want to use this. So let's just start with that first. I need to get rid of miles, so since I had miles in the numerator in my given, I'll make sure miles is in the denominator so that they cancel out. Okay, and I'll just go ahead and use that conversion. So 1 mile equals 1.609 kilometers. And that lets me cross off the miles. Now I'm in kilometers. I need to get to meters. According to King Henry Died by Drinking Chocolate Milk, there are 1,000 meters in 1 kilometer. And that lets me cross off the kilometer. Now I'm in meters, which is great. But I still have the hours over here, which I didn't want because I need meters per second, not meters per hour. So let's try to tackle that next. Since hour was in my denominator in the given, I'll make sure that hour is in the numerator to try to cancel that out. So how can I get hours closer to seconds? Well, let's just go through minutes. So in 1 hour, there are 60 minutes. I'm going to have to come down here and continue it. So that lets me cross off hour. Now I need to try to get rid of minutes and get to seconds as my last step. Minutes was my denominator. Now I need to make sure minutes is in my numerator so that they cross off. And in 1 minute, there are 60 seconds. Now I can cross off minutes. And yay, I am left only with meter that was not crossed off and second that was not crossed off, which is exactly what I wanted to end on. And when we put this into our calculator, we get 27.7105. I can only have 2 sig figs though because my given had 62 as the number. That 62 has 2 sig figs, so I need to round 27.7105 to 2 sig figs, and that will get me to 28 meters per second as my final answer. Alright, so let's look here. This one you're going to want to look at your handout for, and it's going to follow along with that. So you'll have it already written out, and you have a little space that you can try these. So this one works a little bit different because we need to figure out if a liquid has a volume of 2.46 kiloliters. What is this volume in centiliters? We've not used liters before, but it will work the same way as everything else because, again, we have kiloliters, so we have that prefix kila, and then we've got the centiliters, so that prefix centa, and the beauty of this is that it all works the same because they're all powers of 10, and that's awesome. So we'll start off with my given 2.46 kiloliters over 1. Now, if I want to go through liters as the base, I can do that. And I know that my kiloliters will go down here so that I can cross it off. And I know that in 1 kiloliter, there are 1,000 liters. I got rid of that, got rid of that. Cool. Now I'm in liters, and I will make sure that liters is in the denominator so that those end up canceling out. And I know that in 1 liter there are 100 centiliters. That's just like if I asked you how many centimeters are in a meter stick, hopefully you would say 100. And if you wouldn't say that, then we'll just become more familiar with it as we work with the metric system. Okay, so there is an easier way to figure this out. And that is, again, just by looking at the stair steps, because if you move however many steps it takes to go from kiloliters to centiliters, we could simply just change the decimal. So, for instance, we started off with 2.46. I needed to move 5 places, and I need to move those 5 places to the right. 1, 2, 3, 4, 5. We saw this example before. And so my final answer will be 24600 centiliters. Okay, so you can either do the dimensional analysis, and that's completely fine. And in this case, I went through my base unit just because I think that's the easiest way to go. But if you want an even easier route, simply just move the decimal place if you count the right number of stair steps to get from one unit to the next. So that's why this one was a little bit different. We actually don't even need dimensional analysis if we don't want to use it. Alright, let's look at this one. We will need dimensional analysis for this. So a person is 60 inches tall. How tall is this person in meters? We are going to go ahead and use our conversion for this, and that is that we have, 2.54 centimeters equals 1 inch. We're going to need that for this one. All right, so a person is 60 inches tall. Put that over 1. Notice that decimal place. That is a way that we can show that both of these digits are significant. So this is a way of communicating that right now the 60 means we have 2 significant figures. It is not the fanciest way of doing this, but it does get the message across. The best way to do this is usually to turn this into scientific notation, but like I said, the message is understood. We have 2 sig figs here, so our final answer is going to have 2 sig figs. Alright, so we need to get from inches to meters. Let's go through that centimeter conversion here. So 1 inch, I don't know why I spelled that out, is 2.54 centimeters. Okay, now I can get rid of my inches, and now I'm left with centimeters. I know that there are 100 centimeters in 1 meter. Again, you could look at the stair steps for that, or you might just also know that there's 100 centimeters in 1 meter. Awesome. And then our calculator would spit out to us 1.524. However, like we said, we can only have 2 significant figures, so we need to round this to just 1.5 meters to have 2 sig figs. Next, so now we're going to use some density equivalence statements in order to figure out the right answer. So a copper penny has a mass of 3.1 grams and a density of 7.2 grams per milliliter. What is the volume of the penny in centimeters cubed? So again, we have 2 givens in this case. We have the 3.1 grams, which is what we're going to start off with, but they've given us a tool to use, and that tool is the 7.2 grams per milliliter. So I'm going to go ahead and set this up like I always have before, and I'll put 3.1 grams over 1. And in order to try to get rid of grams and end only with milliliters, I will just flip-flop the 7.2 grams per milliliter to work in my favor, because I know that if I have grams in the denominator, or the numerator, I'm sorry, here, then I need grams in the denominator here. So I'll go ahead and put 7.2 grams and 1 ml. Again, I got that from this, 7.2 grams per milliliter. Doesn't matter if it's 7.2 grams up top, 1 milliliter on the bottom, or in this case, 7.2 grams on the bottom and 1 milliliter on the top. That's what makes these equivalent statements, is you can flip-flop them to however you need to use them. It's the beauty of it. So now I can cross off grams, left with milliliters. Now, 1 milliliter is actually the same as 1 cubic centimeter. So this was a rather short one. And the calculator should give you 0.43055 or something of the other. And we can only, however, have 2 sig figs. I know we can only have 2 sig figs because I've got 2 sig figs here. I also have 2 sig figs here. So my final answer has to have 2 sig figs. So I'll have 0.43 cubic centimeters as my final answer. Alrighty. The density of lead is 11.4 grams per cubic centimeter. What is the mass of a piece of lead in kilograms that has a volume of 19.84 cubic centimeters? This is the last one that we're going to do together, so if you want to pause right now and give yourself a chance to try this on your own, please do so, and just press play when you're ready to hear the answer. Okay, so we had, again, two things given to us. So we had the density of lead, and we also had More specifically, what we're going to start off with, that we're going to put over 1, and that's the volume that this lead is taking up. So I'll go ahead and put 19.84 cubic centimeters over 1. And I'm going to use that tool that they gave me when they gave me 11.4 grams per centimeters. I'm going to use that to my benefit. I know I need to get rid of centimeters cubed, so I can go ahead and put centimeters cubed down here. That'll be 1 centimeters cubed is the equivalent, not the equivalent, but goes with 11.4 grams. And now I can cross off centimeters cubed. Really can't see these dots very well. Okay. Maybe if I switch this. Maybe that would work. Maybe it would. Okay. So now I'm in grams, and I have to end in kilograms. So I'll put grams down here. According to the stair step, there are 1,000 grams in 1 kilogram, and that allows me to cross off the grams and end in the unit that I wanted to end in, because they wanted it in kilograms. Awesome. So when I plug this into my calculator, I get 0.226176, but I should only have 3 sig figs. Notice in the 2 numbers that were given to me, I had 3 sig figs here, 4 sig figs here. I always want to go with the lesser of the 2 amounts of sig figs, or the lesser number of sig figs in general. So I need 2 sig figs in this case. I don't want that. I want to round, so 0.23 kilograms is my final answer. Okay, so I hope that helped. Hope that made dimensional analysis make more sense. So now you guys can continue on and try the rest of the problems on your own and work together if you need to. And I'll be posting an answer key as well, so you can be checking your work on that. So thanks for listening in.